Good day and welcome to sorting. Here I'll be covering the concepts behind two sorting methods as well as their code. This video assumes that you already know how to work with arrays, for loops and if statements. The two methods we are going to cover are bubble sort and selection sort. Bubble sort is one of the easiest and slowest sorting methods, but is important to know for the CAP syllabus. Speed isn't as important for you because you probably won't be working with more than a few dozen or at most a few hundred data points. Selection sort is not required to be known, but alternative sorting algorithms will earn you more mark in practical assignments, so it is advised to go through another algorithm if possible. Here is our unsorted array. Bubble sort works by running through the array and swapping adjacent numbers depending on which is larger and smaller. I'll be working with sorting in ascending order by default and will show you how to convert to descending later. Now bubble sort looks at the first and second numbers. If the first is smaller than the second, they swap. This is repeated for the second and third and fourth, etc. This is one run-through of this algorithm. Regardless of how your unsorted array started, after one run-through the largest number will be at the correct place. So in your next run-through, you will not be necessary to check the last number. And at the end of your third run-through, it will not be necessary to check the third number anymore, etc. Bubble sort is called bubble sort because the larger numbers bubble towards the top with each run through. Here is the code for bubble sort. Our outer loop for this works as a countdown because if we get to the point where we know the second number is correct and all other numbers are correct, we no longer need to check the first number. Thus, we only need to run through the algorithm a number of times equal to the array size minus 1. Our next loop runs through every number for the first number from the first number to before we know where the correct numbers are. If something isn't right, we swap. Next is selection sort. Selection searches for the smallest number in the array and swaps it with the first place. Then looks at the array excluding the first spot and searches for the smallest number and places it second. This continues until the array is sorted. Here's our unsorted array. First, we have our invisible barrier where our array is looking. Here we are searching for the smallest number and returned 9. Then we swap it with 79. 9 is now not to be looked when we are searching for a smaller number. Next we will see 20 and swap it with 64. This continues until the array is sorted. Here you can see the numbers that are already the smallest on the right side of the barrier. This simple algorithm will not have an issue. Here is the code for selection sort. The position of smallest variable is used to track where the smallest number right side of the barrier is. It starts by assuming the first number is the smallest number, and if a smaller number is found, the position index is changed. Then after all numbers have been searched, the numbers are swapped. Here we have a program that I wrote earlier to show all of these. Well, all this program does is it creates a random array and lets us display it. So here's our random array. When we click bubble sort, it will sort it by bubble method, and if we click selection sort, it sorts by selection method. Most sorting algorithms can be can be learned off by heart, and you do. But if you understand them, you will be able to type them better. This is the code for bubble sort in Delphi, and here is selection sort.